Good day, students. I, Mrs. Madhavi Doshi from Shri Bhatia Junior College of Science, Department of Mathematics, welcomes you all for the second section for the subject of mathematics. In today's section, we are going to discuss the MCQs which were posted to you yesterday for the chapter Matrices. Students, you all must have seen the video in the first section on the topic Introduction to Matrices, and I hope that it has cleared your doubts on the basic concepts. In today's section of MCQs, we are going to do thorough revision of concepts while discussing each and every MCQ. So students, concentrate and let's start our discussion. Students, our first question is, if the order of the matrix A is 3 by 2, then the number of elements in the matrix A is. Students, we know that the number of elements in matrix is equals to number of rows into number of columns. Given matrix A, it is of order 3 by 2. That implies it has 3 rows and 2 columns. Therefore, the number of elements in matrix A is 3 into 2, which is equals to 6. Therefore, our answer is C, 6. Our second question is, if A is a matrix having elements 3, 0, 0k and it is a scalar matrix, then the value of k is. Students, in scalar matrix, all the diagonal elements are equal and non-diagonal elements are equal to 0. Therefore, in the matrix Aij of order 2 by 2, all Aij's is equals to constant for I is equals to j. That implies my A11 should be equal to A22. Therefore, the value for k should be equal to 3. Our third question is, if A is a matrix of order 2 by 2 and the elements are 4, k, 3, 12 and it is a singular matrix, then the value of k is. Hint, if A is a singular matrix, then its determinant value should be equal to 0. Here, determinant of A is equals to 0. So, that implies 4 into 12 minus 3 into k is equals to 0. So, it is 48 minus 3k is equals to 0. Therefore, the answer for k is 16. So, it is option A and the answer is 16. Question number 4. If matrix x034 of order 2 by 2 plus matrix 1y47 of order 2 by 2 is equal to matrix 6 minus 3 7 11 of order 2 by 2, then x comma y is. Here, students, this is the concept of addition of matrices and equality of matrices. So, stepwise if we go, the order of all the matrices used should be the same. Therefore, the matrices here used all have the order 2 by 2. Step 2, using addition of matrices, that is Aij of order 2 by 2 plus Bij of order 2 by 2 is equal to Aij plus Bij of order 2 by 2 for all Inj. Therefore, we get x plus 1, 0 plus y, 3 plus 4, 4 plus 7, a matrix of order 2 by 2. Then using equality of matrices, equate the resultant matrix to 6 minus 3, 7, 11. Therefore, we get x plus 1 is equals to 6, y is equals to minus 3. So, the value of x is 5 and value of y is minus 3. Hence, the answer is option A, x comma y is equals to 5 minus 3. The next question is question number 5. That is, if the matrix x4 of order 1 by 2 into matrix 6, 7 of order 2 by 1 is equals to matrix 40 of order 1 by 1, then the value of x is. So, students, here we have used in the LHS the concept of multiplication of matrices. The rule of multiplication of matrices is column of first matrix should be equal to the row of second matrix. Then only matrix multiplication is possible. So, here we have Aij of order m by p into Bij of order p by n, then the resultant matrix Cij should be of order m into n. Therefore, Cij is equals to summation Aik into Bkj, where I is from 1 to m and j is from 1 to n. That is, here in matrix multiplication, the corresponding elements are multiplied and then added up. So here we get x into 6 plus 4 into 7 is equals to 40. That implies 6x plus 28 is equals to 40. So this gives us 6x is equals to 12. Therefore, x is equals to 2. So our answer is option A, value 2. Question number 6. If B is a matrix of order 2 by 2 and the elements are 1, k, 0, 4 and it is a diagonal matrix, then the value of k is. Students, a square matrix A of order n by n whose elements are aij is said to be a diagonal matrix if all its non-diagonal elements are 0. That is, if A, that is the aij matrix of order n by n, is a diagonal matrix, if aij is equals to 0 for all I not equal to j, that is, all non-diagonal elements should be equal to 0. So what should the value of k be? Yes, k should have the value equal to 0 because it is a non-diagonal element. So the option B, 0, is right. If B is a matrix of order 2 by 1 and the elements are 1, 2, then transpose of the matrix B is. Here students, B is a Bij matrix of order m by n. Then the transpose of the matrix B, that is B transpose, and which are having elements as Bij, is of order n by m for all inj. Here B11 is equals to 1 and it will be same as B11 element of B transpose matrix. B21 is equals to 2 and it will be B12 element in B transpose matrix. Therefore, transpose of B is B transpose, which is equal to the elements 1, 2 of order 1 by 2. Therefore, the option right is B, which is having the answer as 1, 2 matrix of order 1 by 2. Question number 8. If A is A transpose, then the matrix is known as dash. Dear students, by definition of symmetric matrix, a matrix is known as symmetric if Aij is equals to Aj for all inj and at least one element in the diagonal is non-zero. Therefore, a matrix A is said to be symmetric if A transpose is equals to A, that is, the transpose of the matrix is equal to itself. Therefore, the right option is B, symmetric. Question number 9. A matrix having same number of rows and columns is known as dash matrix. Students, by definition of square matrix, a matrix in which the number of rows is equals to number of columns is called a square matrix. Otherwise, it is said to be a rectangular matrix. Thus, Aij of order m by n is said to be a square matrix if m is equals to n. So, the option A, that is square, is right. Question number 10. The minor M12 of matrix 1, 4, 2, 1 of order 2 by 2 is. If we take an element of the determinant and delete the row and column containing that element, the determinant of that element left is called the minor of that element. Therefore, it is denoted by Mij. So, to find the minor M12, delete the row and column in which A12, that is 4, is present. And the resultant element is 2. Taking the determinant of 2, the answer is 2. So, the option A, 2, is right. Question number 11. The minor M11 of matrix 102, 214, 312 of order 3 by 3 is. Students, here once again, according to the definition of minor, if we take an element of the determinant and delete the row and column in which that element is present, then the determinant of the element left is called the minor of that element. It is denoted by Mij. Here minor of A11 is M11, which is obtained by deleting the row and column in which A11, that is 1, is present. So, we obtain the determinant as A22, A23, A32, A33. Therefore, the determinant of 1, 4, 1, 2, which is equals to 2 minus 4, which is equals to minus 2. So option A, that is minus 2, is right. Question number 12. The cofactor A12 of matrix A 1741 of order 2 by 2 is. By the definition of a cofactor of an element, the cofactor of an element Aij, that is the element in the ith row and jth column, is defined as minus 1 raised to I plus j into Mij. That is minus 1 raised to I plus j times the minor of that element. It is denoted by Cij or Aij. Therefore, Aij is minus 1 raised to I plus j into Mij. So, we have to find out here is A12. So, A12 is equals to minus 1 raised to 1 plus 2 into M12, where M12 is a minor obtained by deleting the row and column in which A12, that is 7, is present. So, the resultant element is 4 and the determinant of 4 is 4. So, here M12 is 4. Therefore, A12 is minus 1 raised to 3 into 4, which is equals to minus 4. Therefore, the option C, minus 4, is right. Question number 13. The number of elements in a matrix, which is a row as well as a column matrix, will be dash. Here students, by definition of row matrix, the matrix having order 1 by n or matrix having only one row is called a row matrix. And according to the definition of column matrix, the matrix having order m by 1 or matrix having only one column is called a column matrix. So, a matrix with single element will be row as well as a column matrix. For example, A is a matrix which is having only one element 3, is a row as well as a column matrix. Therefore, the option B, which is equals to 1, is right. Question number 14. If order of the matrix A is 2 by 3 and order of matrix B is 3 by 2, then the order of matrix AB is. Dear students, here we are going to use the concept of multiplication of matrices, where column of first matrix should be equal to row of second matrix, then only matrix multiplication is possible. That is, if Aij is a matrix of order m by p and Bij is a matrix of order p by n, then the product is equals to a matrix of order m by n. That is, the column of the matrix A is given as 3 and the row of the matrix B is also given as 3. So, A is a matrix of order 2 by 3 into B is a matrix of order 3 by 2, then the resultant matrix, that is the product, is equal to the order of 2 by 2. So, option A, 2 by 2, is right. Question number 15. If A is a matrix of order 2 by 2 and the elements are 1, 2, 2, 1, then the value of A square is. Dear students, A square is the product of A into A. So, A square, again if we write down the matrices, it is 1, 2, 2, 1 matrix into matrix 1, 2, 2, 1. What are the rules for matrix multiplication? We multiply the first row of the first matrix into the first column of the second matrix. That is, we multiply the corresponding elements and then add them up. So, here we get 1 into 1 plus 2 into 2. The same procedure is for first row of the first matrix into second column of the second matrix. That is, again we multiply their corresponding elements and then add them up. So, we get 1 into 2 plus 2 into 1. And we follow the same procedure with the second row and the respective two columns of the second matrix. So, it is 2 into 1 plus 1 into 2, 2 into 2 plus 1 into 1. So, the answer is 5, 4, 4, 5. The resultant matrix is also of the order 2 by 2. Therefore, the option A is right. Question number 16. If A is a matrix of order 2 by 2 and the elements are 3, 4, 5, 7, then the value of A into I is, where I is a unit matrix of order 2. Dear students, we know that when we multiply a matrix A with the identity matrix, we get the same matrix as the answer. So, A into I is equals to A, which is equals to I into A. So, A into I is elements of the matrix A, that is 3, 4, 5, 7 into elements of the identity matrix, that is 1, 0, 0, 1. So, here we multiply the two matrices A into I, we use the same rules of multiplication. So, here it is the product of the corresponding elements of the first row of the first matrix into the first column of the second matrix. So, we get the answer as 3 into 1 and plus 4 into 0. That is, we multiply the corresponding elements and then add them up. The same thing with the first row of the first matrix into the second column of the second matrix. That is, we multiply the corresponding elements and add them up. So, we get 3 into 0 plus 4 into 1. This is over with the first row of the first matrix. Now, we follow with the same procedure for the second row of the first matrix and the corresponding elements of the two columns of the second matrix. So, we have 5 into 1 plus 7 into 0, 5 into 0 plus 7 into 1. So, your answer is 3 plus 0, 0 plus 4, 5 plus 0, 0 plus 7, which is equals to 3, 4, 5, 7, that is the matrix A itself. So, the option A is right. Question number 70. The cofactor Aij is equals to minus 1 raised to dash into Mij. Dear students, according to the definition of the cofactor of an element, the cofactor of an element Aij, that is the element in the ith row and jth column, is defined as minus 1 raised to I plus j times the minor of that element. It is denoted by Cij or Aij. Therefore, Cij or Aij is equal to minus 1 raised to I plus j into Mij. Therefore, the option B, I plus j, is right. Question number 18. If A is 4, 8, minus 2, minus 4, a matrix of order 2 by 2, then value of A square is? Dear students, we know that A square is A into A. So, when we multiply the same matrix by itself, we will get the answer as, that is, when we are multiplying the two matrices, we are multiplying the first row of the first matrix with the first column of the second matrix. That is, we multiply the corresponding elements and then add them up. So, we get it as 4 into 4 plus 8 into minus 2. The same procedure with the first row of the first matrix into second column of the second matrix. So, we get it as 4 into 8 plus 8 into minus 4. Now, we repeat with the second row of the first matrix and the corresponding two columns of the second matrix. So, we get minus 2 into 4 plus minus 4 into minus 2, minus 2 into 8 plus minus 4 into minus 4. So, your answer is the matrix of 16 minus 16, 32 minus 32, minus 8 plus 8, minus 16 plus 16. So, the resultant matrix is a 0 matrix of order 2 by 2. Therefore, the option A, null matrix, is right. Question number 19. In matrix system, A plus B whole square is equals to A square plus dash plus B square. Dear students, in general, commutative law does not hold in matrix multiplication. That is, here the product of AB is not equal to product of BA. So, when we have A plus B whole square, we will have to write it as A plus B into A plus B. And when we multiply these two matrices, we get as A into A plus AB plus BA plus B into B. A into A is A square, B into B is B square. So, the resultant answer is A square plus AB plus BA plus B square. So, the answer option A, that is AB plus BA, is right. Question number 20. In matrix system, A minus B whole square is equals to A square plus dash plus B square. So, students, here also the same thing that a commutative law does not hold in matrix multiplication follows. That is, AB is not equal to BA. Therefore, A minus B whole square has to be written as A minus B into A minus B, and we have to multiply these two matrices. So, we get the resultant answer as A into A minus A into B minus B into A plus B into B. So, we get it as A square minus AB minus BA plus B square. Therefore, the option A, minus AB minus BA, is right. Question number 21. In matrix system, AB is equals to BA, then A plus B into A minus B is equals to dash. Dear students, we know that in general commutative law does not hold for matrix multiplication. That is, AB is not equal to BA. But here it is an exceptional case because we are given that AB is equals to BA. Therefore, A plus B into A minus B is A into A minus A into B plus B into A minus B into B, which is equals to A square minus AB plus BA minus B square. But given is AB is equals to BA. Therefore, we get the answer as A square minus B square. Therefore, the option A square minus B square is right. Our next set of questions is based on to find the inverse by adjoint method. The formula we are going to use is A inverse is equals to 1 upon determinant of A into adjoint A. So, for question number 22, if A is a matrix of order 2 by 2 and the elements are 4, 2, 6, 2, then the value of A inverse is. Dear students, let us find the determinant of A. So, determinant of A is determinant of 4, 2, 6, 2, which is equals to 4 into 2 minus 6 into 2, that is 8 minus 12, which is equals to minus 4, not equal to 0. Therefore, matrix A is invertible. Therefore, A inverse exists. Next, we will find the cofactors. The formula to find the cofactors is Aij is equals to minus 1 raised to I plus j into Mij, where Mij are the minors. So, A11 is equals to minus 1 raised to 1 plus 1 into M11. So, it is minus 1 square into 2. 2 is obtained by deleting the row and column in which A11 is present and taking the determinant of the resultant element. The determinant of the resultant element is 2. That is why M11 is 2. So, the answer for A11 is 1 into 2, which is equals to 2. A12 is minus 1 raised to 1 plus 2 into M12, which is equals to minus 1 into 6, which is equals to minus 6. A21 is equals to minus 1 raised to 2 plus 1 into M21. So, which is equals to minus 1 raised to 3 into 2, which is equals to minus 2. A22 is equals to minus 1 raised to 2 plus 2 into M22, which is equals to minus 1 raised to 4 into 4, which is equals to 4, where M11, M12, M21, M22 are the minors. Therefore, the cofactor matrix C is A11, A12, A21, A22. That is the matrix of the elements 2, minus 6, minus 2, 4. Therefore, the adjoint of A is cofactor transpose. That is the transpose of the matrix 2, minus 6, minus 2, 4, which will get the answer as 2, minus 2, minus 6, 4 matrix. Therefore, A inverse is 1 upon determinant of A into adjoint of A. So, it is 1 upon minus 4 into the matrix 2, minus 2, minus 6, 4. Therefore, the option A is right. Students, for question number 23, we have to follow adjoint method, but it is quite tedious for MCQs. So, from now onwards, for the rest of the questions, I am going to use A inverse by shortcut method. Question number 23. If A is a matrix of order 2 by 2 and the elements are 1, 2, 3, 4, then the value of A inverse is. According to shortcut method, if A is a matrix of order 2 by 2 and the elements are A, B, C, D, then A inverse is 1 upon AD minus BC into matrix D minus B minus C A. Therefore, A inverse is 1 upon 1 into 4 minus 2 into 3 into matrix 4 minus 2 minus 3 1, where 4 and 1 are obtained by interchanging the elements in the diagonal and minus 2 minus 3 are obtained by multiplying the non-diagonal elements with minus 1. So, the resultant answer is 1 upon 4 minus 6 into the matrix 4 minus 2 minus 3 1, which is equals to 1 upon minus 2 into the matrix 4 minus 2 minus 3 1. Therefore, the option B is right. Question number 24. If A is a matrix of order 2 by 2 and the elements are 3, 4, 2, 3, then the value of A inverse is. According to shortcut method, if A is a matrix of order 2 by 2 and the elements are A, B, C, D, then A inverse is 1 upon AD minus BC into matrix D minus B minus C A. Therefore, A inverse is equals to 1 upon 3 into 3 minus 2 into 4 into matrix 3 minus 4 minus 2 3, where 3 and 3 are the elements obtained by interchanging the elements in the diagonal, and minus 4, minus 2 are obtained by applying minus sign to the non-diagonal elements. So, the answer is 1 upon 9 minus 8 into matrix 3 minus 4 minus 2 3, which is equals to 1 upon 1 in matrix 3 minus 4 minus 2 3. Therefore, it is equal to the matrix 3 minus 4 minus 2 3 of order 2 by 2. Therefore, option B is right. Question number 25. If A is a matrix of order 2 by 2 and the elements are 3 0 0 3, then the value of A inverse is. By shortcut method, that is, if A is a matrix of order 2 by 2 and the elements are A, B, C, D, then A inverse is 1 upon AD minus BC into matrix D minus B minus C A. Therefore, A inverse is 1 upon 3 into 3 minus 0 into 0 into the matrix 3 0 0 3, which is equals to 1 by 9 into matrix 3 0 0 3. So, which is here we are going to use the scalar multiplication. That is, we are going to multiply each and every element of the matrix by the scalar. Here the scalar is 1 by 9 and the elements are 3 0 0 3 of the matrix. So, we will multiply with the matrix with the scalar. So, we will get it as 3 by 9 0 0 3 by 9, which is equals to 1 by 3 0 0 1 by 3. Therefore, the option A is right. So, students, we end our journey to the MCQs of the chapter Matrices. Hope all your doubts to the introduction of matrices is cleared. Students, please revise all the concepts thoroughly as they are very much required for 12th standard. Dear students, we will be meeting very soon with our next section on the topic compound angles, which has lot of views for 12th standard. Till then, students, be safe, be happy, be calm and stay connected to us. Thank you.